You are welcome to Math Demystified.
Let's take a look at some special angles. You need to know the special angles properly. Sometimes they ask you to leave your answer in short form, and the special angles will help you. So let me start with 30 and 60. If I have a triangle like this, where all the sides are equal, let's call this 2, call this 2, call it 2. I can call it any number, but 2 is the one we always use. In this case, this will be 60 degrees. Here it will be 60 degrees, this will be 60 degrees because it's an equilateral triangle. If I draw a line here to bisect this lower line, now this part will be 30 degrees, and here will be 90 degrees. So, and this one is 2, we call 1 and 1. So the triangle you have here is a mirror of this other triangle. So you see, you have 2, we have 2, we have 1, 1, we have 60, 60, 30, 30. So I'll just take one of the triangles out. Let's bring out this side. So we have 1, we have 2, we have 60 degrees, we have 30 degrees. Now let's quickly find this place. Let's call it X. So let's use Pythagoras. You know, I told you when you have two sides, then I'm looking for the top side, use Pythagoras. And this one is not the hypotenuse. So I'm going to have 2 square minus 1 square. And that will give me 4 minus 1. So my x square is equal to 3. So that my x is root 3. So this place is root 3. So if I'm looking for sine 30 degrees, or I'm looking for cos 30 degrees, tan 30 degrees. We also look for sine 60 degrees. Then we look for cos 60 degrees. Then tan 60 degrees. Let's do that quickly using your calculator. So this 30 degrees, this is the opposite. This is the hypotenuse. So this is half the cosine. That is root 3 over 2. The tangent, 1 over root 3, which can be written as root 3 over 3. If you know your sort very well, then you have 60 opposite over hypotenuse. That's root 3 over 2. Then I'm looking for cosine. That will be adjacent over hypotenuse, 1 over 2. Then my tangent, that's root 3 over 1, which is root 3. All this you need to know. They are all special angles. So this is the trig ratio of the special angles. Take note of what we did before. We discovered that my sine 30, we said is equal to what, if you remember? Sine. Let me remind you again. Sine theta was equal to cos 90 minus theta. So if I say sine 30 in this case, this will be 90 minus 30 should be equal to cos 60. And that's what is happening over here too. Sine 30 and cos 60 are both half. And we did the same thing. We said if I put cos here, this one will change to sine. If I put 30 here, this will become 60. While this one will now be cos 30, and this will now be sine 60. That's exactly what happened. Cos 30, sine 60 are exactly the same thing. And we also learned that this divided by this is the same thing as tan 30. If you divide this, that's what you will have. So everything we have learned is very important. Please do not like some and hate some. You must like all of them. That's why I'm taking my time to break them down one after the other. Now, for angle 45, let's draw an isosceles triangle. And make this 90 degrees so that this and this are equal. And if I find this side to give me root 2 using Pythagoras, let me draw it like this. While this is 1, 1, and here will be root 2 using Pythagoras. So if I do, because this is 90 and it's an isosceles triangle, this is 45 degrees, 45 degrees, this is 45 degrees, this is 45 degrees. So I'm looking for sine 45 cos 45 degrees and tan 45 degrees. What do you think sine 45 degrees will be? Opposite over hypotenuse, 1 over root 2. What do you think cos 45 will be? 1 over root 2. All this can also be written as root 2 over 2. This one too as root 2 over 2. Then tan is 1 because it's opposite over adjacent. Now if you go back to what we did before too, sine 45 is supposed to be cos 90 minus 45, which happens to be 45 also. And that's why the two answers are the same if you look at it properly. So master all this. We have done 3 special angles. We have done 30, we have done 45, we have done 60. We are going to do some other ones. So I'm going to draw a diagram to help us fix some basic ones too. So let's have this running sine graph where this is 0, this is 180, and this is 360. Let me call this theta. Let's call this y. Now, if this is 0 and this is 180, this center is 90, this center is 270. Now, this place is 1, while this place is minus 1. Let me explain how to read this graph to you. This graph that we have is y equals sine theta. I could call this x, I could call it any alphabet, does not matter. Don't forget that all the y values are read like this, are read horizontally, whereas all these theta values are read vertically. All the y values, for instance, if I have a graph like this and this is 0, and I put 1 here, I put minus 1, put 1, put 2. If I ask you if this is x and this is y, and I say, what is x equals 1? This is x equals 1, x equals 2, x equals 0. So x equals 0 is y-axis. If I ask you what is y equals 1, this is y equals 1, y equals 2, y equals minus 1, y equals 0 is x-axis. So same thing with this. The y you see here is just the y-axis. All the y values are like this. So all the theta values are like this. So if I have a question that says I should find sine 0, value of y when theta is 0. So when theta is 0, y is also 0. Let's get to 90. When theta is 90, touches this graph here, trace it to y. That's 1. To the next one, sine 180. When theta is 180, trace it is 0. Sine 270 degrees. 70 degrees, this is theta, is touching the graph here, trace it this way, minus 1. Then you have sine 360 degrees. If you trace it and trace it to y, you have 0. These are special angles. These are also special angles. So 0, 90, 180, 270, 360, just like we have 30, 45, and 60. All these ones too are special angles. Okay, let's go to the next one. for cosine. If I have a similar graph, where this one is starting from here and it's moving and it stops there. So this is my 360 and this is my 180, this is my 0, this is my 1, this is my -1. That tells me that this is 90 and this is 270, all the special angles that we did. So this graph we are dealing with here is for cosine, cos theta. So let's call this theta, let's call this y. So try and provide the answers to all of this. You'll see that when theta is 0, at that point y is 1. When theta is 90, at that point y is 0. What I'm trying to do is look for the angle, trace it to the curve, then trace to y. So look for 0, trace to the curve, it touches the curve here and trace to y is 1. 90, touches the curve here, trace to this 0. 180, it touches the curve here, trace it, that's -1. 270, it touches this curve here, trace, that's 0. Then 360, you trace it, it touches the curve here, trace it to the y, you get 1. Please take note of all of this.
If you enjoyed our teaching, please click like and feel free to share our link with your friends, and do not forget to subscribe to our channel so that you can get notifications of our subsequent videos.